Good morning, I'm Federico Seri from NUIG, and this video is a short demo about the ModSCO tool and its application to the TNO pilot, which is a demonstrator of the Sphere project. What is ModSCO? ModSCO is a tool that uses a reduced order gray box model developed with the MODELICA language and is equipped also with a graphical user interface. Through the graphical user interface, the user can input the characteristic of a certain building, generate a simulation model for the building, and testing different envelope retrofit packages or control settings in order to evaluate the performance of the building and potential energy savings due to the application of these retrofit packages using international performance measurement and verification protocol. So the main goal of ModSCO is to generate an accurate baseline of energy consumption for a building that can be used in the future for comparison with potential implementation of energy conservation measure or detect unexpected energy behavioral changing of the building. If you are in a design phase of your building, you can find the best retrofit solution within the available ones before the implementation using a short amount of building data in a fast, accurate way. Or if you already apply a renovation measure to your building, you can estimate energy savings resulting from it. Why ModSCO is innovative? A recent critical review from 2021 compared the available tools for building simulation based on gray box model in the market, and this review compared those tools based on 5 features. And ModSCO is the only one that has all these features, and plus through the Sphere project want to add an additional feature that is the beam data import one. So this is the welcome page of ModSCO, where the user need to sign up and then sign in with the same credential in order to get access to the graphical user interface of ModSCO. The process is quite straightforward, and once you do the sign in, you're gonna get access to the software. This is the graphical user interface of ModSCO. In the top part, you can see different Excel tools, and the user had to start a new project. Let's call TNO as the pilot name, and test 1 is the first building simulation model that we want to generate. Here you can see different building parameters that needs to be filled up by the user on the next steps, but as first step the user has to download these 4 Excel spreadsheets that are ROMPAR, schedule generator, internal gain calculator, and the weather file. Once this operation is concluded, we move to ROMPAR. Rompar is an Excel tool that is used to calculate the building parameters. That in gray box models are resistance and capacitance that enable the possibility to generate a mathematical model for your building. So we have material database that contains already the most common materials in construction sector with their properties, and the database is made in a way that can be customized by the user. The user can include, in this case, for example, a new window, triple glazing window with their properties, or an opaque material as the one that we are showing in the bottom that has been added for the TNO pilot. And once this operation is done, the user is sure that in the description of the envelope, so the next step, he can describe every type of wall, different type of wall, by the materials and their thickness on the layer. Selecting from this menu, the user can select the material from the previous database and describe the wall. This operation needs to be performed for every wall that is different in stratigraphy. And for example, if you modified the thickness on the right side of the spreadsheet, it's modified the graphical visualization, so the user can take track of what is changing every time it change thickness. And also he has to define the total surface of each wall. So to make this process short on the description of this video, this is pretty similar for the different spreadsheets. So glasses external, so external windows, ground floor, internal partition, roof, and internal windows or glasses. And then the last one is the definition of properties of the glasses as solar factor. Once the user fulfill all of this, practically can go to the starting part of the spreadsheet, debug, so no error are present, and export and save a txt file that will be used later on in the graphical user interface. This second Excel tool is called Schedule Generator. So it generates scheduling for people, lighting equipment, heating and cooling system. And practically there are two main spreadsheets. The schedule calendar that describe the weekly and the annually profile, and the daily profile is defined on the second schedule profiles. Easily the user can define his working hours or occupancy during the week. It depends if it's an office or an house. And the annual holidays or period when he's in vacation. Once he defines this through the schedule profile, you can visualize and define a percentage of occupancy for a particular day during the week, and also you can visualize this on a graphical way on the right side of the spreadsheet. The same process can be performed for also equipment in a matter of what time of the day is functioning. And as you can see, for example, modifying these values provide a graphical feedback on the right side of the schedule profile. So this is performed for every different schedule, and at the end the user needs to generate and export the different TX file for lighting, equipment, heating and cooling and people. And all these TXT files are saved on the laptop. This is the last tool, is internal gain calculator, and it's really a simple tool. It calculates the gain, the load from the people. In this case, it's a residential building, so we include the number of people, the activity, and we get the value of the people heat gain to be included in the graphical user interface later on. So this is the final phase to build a building simulation model for your building. So the user needs to fill up the following parameters that are building latitude, building volume, building type, and the user then needs to upload the txt file that is saved from the Excel tools that we described in the previous slides. So one by one, those files need to be uploaded, and I'm gonna speed up a bit this process. So we get to the phase where also the weather file is uploaded, and we define the heat gain per people from the heat gain calculator. Then we include other values based on data sheets of the equipment and use of the equipment itself, as for example temperature set points, and those values, in case the user doesn't know, for example, inflation rate, are defined in the guide that NUIG provides to the user. And in this case, we don't have real data, so we cannot calibrate the model. So we include just value 1 for the calibration parameters. Once we save all of this, we are ready to perform a simulation of energy simulation for your building. Just using the save button and then run simulation. So we are ready to run the simulation. Once you run the simulation, you will get an email with the results. And if you download this final Excel tool, you can upload the results in this Excel tool, and this Excel tool will show you, in this case, we can see the electrical consumption in kilowatt per hour during the year on a monthly basis for your building. And in case you have also real data, you can use this tool. So if you have energy bills, you can split your energy bills by monthly energy consumption and use this value and this tool to calibrate your model, taking into account criteria based on IPMVP protocol. So you generate a baseline energy consumption for your building considering those criteria as let's say you understand the accuracy and the consistency of your results. I hope that you enjoyed this short presentation of ModSCO, and please keep visiting our website InSphere to have new updates on the tool. Thank you for your attention.